Today, we are going to move on to circles, okay? So we're still in our geometry bubble, but we're going to move on to circles. And for the next couple days, we're going to look at circles, and we're going to understand the parts of a circle and then measurements of a circle, okay? Now, Connor, you don't have to write. I will get you notes eventually. I'll write out the notes, but just follow along, right? So, today we're going to focus on the circumference of a circle. The circumference of a circle is the distance around the circle. So it's kind of like the perimeter of a circle. Okay? Now perimeter, when we talk about perimeter of an object, of a two-dimensional object, perimeter is of a polygon, right? Okay, so this is a polygon because it's got many sides. It's a rectangle. If this side is 2, this side is 2, this side is 4, this side is 4, and we add up all the sides to get the perimeter, right? The circumference of a circle is the distance around the circle, but can we add sides on a circle? No, because a circle is not a polygon. A circle is a two-dimensional figure, but it's not a polygon because it doesn't have any sides. So, when we look at a circle, there are several different parts of a circle. The first part here is the diameter. Now the diameter is the distance across the circle. And when I say the distance across, it has to go through this point right here. What is that point? Anyone know?
A radius.
No?
The center.
The center, very good. So this is the very center of a circle. The center is equal distance from every single point along the circle. The diameter is the distance across the circle, and it has to go through the center. Is the distance across the circle through the center. Now the other part is the radius. The radius is the measurement from a center to an outside point on the circle. Okay. What's the relationship between the radius and the diameter? Anyone know? What does it look like? This is, okay, all the way across, right? And this is, yeah, so this is how much across? About, okay. It's about half. Okay. So the radius is half of the diameter. So we could actually say that the radius is equal to the diameter divided by 2, correct? So then that means the diameter is 2 radii. So 2 times the radius. So 2 of them make up, 2 radii make up the diameter. Half of the diameter makes up the radius. So I use the term radius and radii. Radius is 1. Radii is more than 1. Okay? So radii is the plural of radius. So our last definition is this one here. And that's the circumference of a circle. The circumference is the distance around. Okay? So again, if it was a polygon, we'd call that the perimeter. In a circle, we call that the circumference. Okay. So, the circumference of a circle is the distance around the circle, right? Do I have a circle here? Yeah, well this is a cylinder, the end is a, okay. So if I find the measurement around, can I do that with this piece of paper? snickerdoodles, so I need a bigger one. Let's see what I got. Clean out my canvas yesterday, so I should have something large. Can you stop picking yourself right now? That's disgusting. Do you need a Band-Aid?
No.
Need lotion?
No.
Okay, here we go. Ready? So I wrap this around, and I can now get the measurement of my circle. Okay, do you see what I'm doing here? Okay, so I'm going to make a little dot where these two overlap. Okay, so I started here, and I went all the way to this point here. I have a black marker somewhere. So this right here from here to here is the circumference of my circle, right? Okay, so if I were to measure this distance here, no, I get 12 inches plus 6/16. So 1 6/16. So that's 13 3/8. 13 3/8 inches. Does that make sense to everybody? Okay. So the distance around my circle was 13 3/8 of an inch. Okay, so that was the circumference. That's the value all the way around. If I take the diameter of my circle, which is all the way across, got it? Right? So if I measure accurately the distance across, I get 4 1/4. Okay? So my circumference is 13 3/8 of an inch. My diameter, I said, was 4 1/4, correct? So if I take those values and I divide them, okay, so I'm going to go, let's see, what is 3/8? 375. And then that's 4.25. Okay, so if I go 13.375 divided by 14.25, I get this number. So I took 13 3/75 and divided 4 25/100, and I got this number. What do you notice about that number?
Not repeating?
Okay, it's not repeating, so we know it's what kind of number if it's not repeating. What's that word? Starts with an I.
Independent?
Nope. Did you say it? Sorry, Ann, I didn't hear it. Irrational number. What other kind of number is irrational? Like the most famous irrational number. Pi. Okay? On your calculators, if you have this one here, I want you to press the pi button and then enter. Pi button is down, is 4 down from the second button. Is it close to this? Ish? 3.14. This is 7250888 24. Pi is 3.14159265535, da 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 da, goes on and on forever. Is it relatively close? Yeah. So circumference is the ratio of, pi is the ratio of the circumference divided by the diameter. So if we want to calculate the circumference of a circle, we use the formula C equals pi times diameter. So this is the formula for the circumference of a circle. So circumference of a circle, C equals pi times D. Now, do we use the term pi? Like, do we have to type in 3.14159265535, da 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 da? Do we do that? What do we typically use? Anyone know?
Circumference over diameter.
What?
Circumference over diameter.
No. What do you think we would use? We're not going to use the whole thing. 3.14. Okay? So for our purposes as 7th grade math students, we use the approximation of pi as 3.14. Yeah, you can use a pi button and get a way more accurate answer. But mainly if someone's going to ask you to calculate something with pi, they're going to use the term 3.14. So let's look at a problem. Mark recently replaced his front bicycle wheel. How far does the bike travel with each revolution of his new front wheel? So here's his front wheel. What we're trying to figure out is how far he can go on one revolution. So that means the point where he starts and then the point where he stops one time around, correct? Kind of like you're on a Ferris wheel, because you go one time around, right? So if the diameter is 26 inches, what measurement are we trying to find? Yeah, the circumference. The circumference is how far a circle can go in one revolution. So we're going to use the formula C equals pi times the diameter. Because that'll give us the circumference of our circle, or one revolution of our circle. So basically what I'm saying is if I start here, I want to know how far we can go till I get here. Does that make sense to everybody? Okay, I want to know how far this whole distance is. Okay, that's what I'm looking for. So circumference is equal to pi times the diameter. So circumference is equal to pi. What are we using for pi? And what's the diameter of our bike wheel? 26. So when two numbers are together, right next to each other, what operation are we doing? Multiplication. Okay, so go ahead and use your calculator. Oh, okay, I was going to do okay, thank you so much. Yeah, bye-bye. What we got?
81.84.
Okay. 81 and 6400? Okay. So our circumference is 81 and 64 hundredths inches. Okay? So, on that tire, okay, these tiles here are 12 inches. Okay, so someone do 81 and 6400ths divided by 12 for me. Divided by 12, yep. 6.8?
Yeah.
Okay, so 6 and 8 tenths. So 8 tenths is 4 fifths, right? Okay, so if we're on that bicycle, one revolution, we're going from here, Mason, stand right here. Okay, so we're going 1, 2, 3, 4, 5, 6. Was it 6 or 8? So we're going this far on one bike revolution, one tire. Okay, so that was the from here to here on one tire revolution. So if we took this bike tire and we cut it and we laid it out between me and Mason, we'd get 81 and 64 hundredths of an inch, which is from me to Mason. It's a big bike tire. Right? But those road bikes, they do have very large tires. They're really skinny, but they have large tires. Go ahead, sit down. Thank you. So that's how we use information to calculate the distance around a circle. Okay. So if I took my Clorox bottle, the end of my Clorox bottle, I said that my diameter was 4 and 25 hundredths. Okay, so if I take 4 and 25 hundredths and multiply it by pi, I should be pretty close to this. I should be pretty close to this, correct? Okay, because that's diameter times pi, which is circumference of a circle. So if I take 4 and 25 hundredths and multiply it by 3.14, I get 13 and 345 thousandths. Is that pretty close to this number?
Yeah.
Absolutely it is. Now, why is it not exact? Well, there's measurement error. Do you agree? Okay, these sides here are curved, so it's not a perfect circle. So I made my best estimate with 4 and 25 hundredths. It's not, how far was I off? About 35 thousandths? Is that right? That's pretty good. It's a pretty good measurement. What if you only had the radius? Could you still calculate the circumference?
Yes.
Okay, Tucker, say it again.
You do your radius times 2, and you do your diameter.
Very good. So, circumference, we said, was pi times the diameter. But if I only have the radius, how many radii do I need to make one diameter?
2.
I need 2. So I can say 2 pi r. So 2 radii times the pi is going to be, if you have radius. If you have diameter, pi r, or just pi times diameter. If you have your radius, 2 pi r, because you need 2 radii to make one diameter. So our problem is, what's the circumference of the rim of a basketball hoop that has a radius of 9 inches?
18.
Okay, so we're using 18 for what? The diameter. Okay, so if I do that, I could do that, right? Or I could do this. Should I get the same value?
Yes.
Absolutely, you should get the same value. So our problem here says first multiply the radius by 2 to get the diameter, which is 18 inches. Then multiply the diameter by 3.14, an approximation of pi, to get the circumference. So if I do that, 3.14 times 18. $56 and 52/100? I want you to do this one. 2 times 3.14 times 9. Same thing, right? Does it matter which formula you use? You get the exact same thing. Now the problem is you have to understand, when do I use the diameter, when do I use the radius formula, right? Or you can always use the diameter formula, but you just need to double the radius when you see a radius. Kayla and Theo got on the Ferris wheel shown. About how high will they be at the top of the Ferris wheel? So if they get on down here, okay, and they know they're going to travel 220 feet when they go all the way around. How high off the ground are they when they're at the top? So what we're looking for is we're looking for the measurement between the bottom and the top. What is that part of our circle? The distance across, which is the diameter. So the formula we use is circumference is equal to pi times the diameter. What information do we have? We have the circumference. So we have 220 is equal to 3.14 times the diameter. Do you know how to solve a one-step equation? Yeah. What's happening between 3.14 and D? Multiplying. So what do we need to do to get rid of it? We need to divide it. So if we divide both sides by 3.14, we cancel 3.14 out, what are we left with? D, which is our diameter. $70 and 110. Anyone else get 70 and 110? Well, you got 70.0636947, right? Are we going to write all those numbers out? Oh, heck no. We're going to round to the nearest tenth or the nearest hundredth. So nearest tenth would give us 70 and 1/10, and that is feet. So that means there's 70 and 1/10 feet off the ground. So that means 70 of these tiles. That's how far they would be off the ground. Okay? So our room, I think, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. About 26, maybe 27. Yeah. So we take that, probably about a 2.5. And that's how high they would be off the ground in the Ferris wheel. That's a way, well, how far away up, right?
Ferris wheels are
It's
scary.
Times 3, it's 78, yeah.
Ferris wheels are scary.
Yeah, I would rather,
I don't want Ferris wheels.
I'd go on Millennium, Top Thrill, whatever. I'd go on those a million times before I would get on the Ferris wheel.
That's the worst thing ever.
What, bro? What? No. You love Ferris wheels? Do you know what else I don't like? You know those sky cars that go all the way across?
The cable's like
Okay, nope. Put me on Millennium a million times. Put me on Top Thrill a million times. Let me roll back on Top Thrill.
Yeah,
Okay? Let me do that before I will get on those. Do you know who loves those? Grayson. So what do I have to do every time I go to Cedar Point? And I'm like, and he's like, he wants to look over the side. I'm like, oh dear God, I can't handle this. But man, I'm like, Top Thrill? Let's go. I get all jazzed up to get on Top Thrill. Not on those things. I'm shaking. Yes, dear.
So we were doing the sky card or whatever, and like everybody on there was just freaking out because the cables were shaking.
Oh yeah, because they bounce. Because once they go up over the thing, they go woo, woo, loop. No,
No, I would rather go on a Ferris wheel.
No.
At least it doesn't swing.
no, not me. No,
The thing is,
no. I just want to go fast.
I was just scared that the Ferris wheel
Like in Final Destination or one of those movies. All right, guys. So you are going to have homework. You've got 4 problems. Okay. So your priority are the first 3. The 4th one is a challenge. Okay. So your priority is the first 3. The 4th one is a challenge. Okay. But you haven't had math homework all week, right? So you can go ahead and do those 3 problems. Again, the 4th problem is a challenge.